Okay. Welcome once again. We'll start from, sorry, I think, just pardon me. Let me scroll to the beginning and then we'll start from there. Okay. So we'll look at the 2020 questions now and we'll look at them stepwise. I'll give the answers and then the explanation for why the answer chosen was picked. So we'll start with the first question that says that the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, and 3p3. How many unpaired electrons are there in the element? How many unpaired electrons are there in the element? Is it A, 5? Is it B, 4? Is it C, 3, or D, 2? Looking at the options carefully, we can say conveniently that the right answer is option C, which is 3. Now, the reason for this is because the configuration corresponds to phosphorus, that's atomic number 15. The 3p orbital can hold up to 6 electrons, but has only 3 electrons. So according to Horn's rule, these electrons occupy separate orbitals before pairing. So there are 3 unpaired electrons in the 3p subshell. So that's the reason for choosing that particular option. Okay. So we'll move along now. The second question says, which of the following can be obtained by fractional distillation? Which of the following can be obtained by fractional distillation? Nitrogen from liquid air. B, sodium chloride from sea water. So looking at the second question here, yeah. So looking at the second question, which of the following can be obtained by fractional distillation? Which of the following can be obtained by fractional distillation? A, nitrogen from liquid air, sodium chloride from sea water, iodine from solution of iodine in carbon tetrachloride, D, sulfur from the solution of sulfur in carbon disulfide. So when we look at all the options that are listed, the right answer to this one is option A, nitrogen from liquid air. Now, basically, fractional distillation separates components based on differences in their boiling points. So liquid air is separated into nitrogen, oxygen, etc. by fractional distillation. Others involve crystallization or extraction method. So the right option or the right answer is nitrogen from liquid air. And that's what we use fractional distillation to separate its components. Okay. The third question is, duralumin consists of aluminum, copper, and dash. Is it A, zinc and gold, B, lead and manganese, C, nickel and silver, D, manganese and magnesium? What do you feel the right option is? Let me know. Okay. So the right option is manganese and magnesium. Manganese and magnesium. So it consists of aluminum, copper, then manganese and magnesium. So duralumin is a light, strong alloy made of aluminum, which is the main element, then copper and manganese and magnesium. Okay. Okay. The fourth question says, an example of a polysaccharide is A, dextrose, B, mannose, G, glucose, D, starch. The right answer is starch is a polysaccharide. And the reason is because polysaccharides are complex carbohydrates made up of many sugar units. Starch is a polysaccharide. The others are monosaccharides. That is simple sugar. Okay. 8 grams of methane occupies 11.2 at 11.2 at STP. What volume would 22 grams of propane occupy under the same condition? Is it 3.7 dm cube, 11.2 dm cube, 22.4 dm cube, or 33 dm cube? The right answer here is 11.2 dm cube. And how do we arrive at this? The first thing is that we know the moles of methane, which is 8/16, that's 0.5 mole. That is 0.5 moles occupies 11.2 dm cube. 0.5 moles occupies 11.2 dm cube. Therefore, 1 mole will be equal to what? 22.4 dm cube. 22.4 dm cube. Now, step 2, the mole for propane is 22 divided by 44. How did I arrive at this particular figure? It's just taking the mass that was given to us, dividing it by the molar mass, and that will give us the number of moles. So the number of moles is about 0.5. So the volume 0.5 multiplied by 22.4 dm cube will give us what? 11.2 dm cube. So therefore, the same the volume that 22 grams of propane will occupy under the same condition is 11.2 dm cube. Best first aid treatment for concentrated tetraoxosulfate 6 acid spill on the skin is what? Is it sodium hydroxide solution, iodine solution, sodium triazonitrate 5 solution with cool running water? Okay, so when we look at this critically, the best first aid still remains cool running water over the spill. You can place the affected area under cool running water for like 20 minutes. Just run cool running water over it for like 20 minutes, and it will flush out or wash out all the acid that's spilled on the skin, and then the person can be free from such. Okay. So cool running water is the safest and most immediate treatment for acid burns. Never neutralize strong acid with a strong base on the skin. It can worsen tissue damage due to heat from neutralization. Okay. All right. So we move along now to the next one, and we have a graph. Which of the gas law does this graph illustrate? Which of the gas laws does this graph illustrate? Is it Boyle's law? Is it Charles' law? Is it Gay-Lussac's law or Graham's law? Looking at the 4 options that we have there, you look at it critically and agree with me that it actually illustrates the Charles' law. It illustrates the Charles' law. Now, the graph shows the volume, which is on the y-axis, plotted against the temperature in Kelvin on the x-axis. Then a straight line relationship starting from the origin, that's at 0 Kelvin, with volume increasing proportionally with temperature. So this is a clear depiction of the Charles' law. Okay. And don't forget that the Charles' law states that at constant pressure, the volume of a fixed mass of gas is directly proportional to its absolute temperature in Kelvin. Okay. All right, now let's move to the 8th question. And the question says, what are the possible oxidation numbers of an element if its atomic number is 17? If its atomic number is 17, is it -1 and 7? Is it -1 and 6? Is it -3 and 5? Or -2 and 6? -2 and 6. Okay, let's look at it together. The right option here is -1 and 7. How did we arrive at this? Very simple. Elements with atomic number 17 is chlorine. It commonly exhibits a -1 oxidation state. Basically, the halogen family, that's the group 7, or we call them group 17, depending on how you look at it in the periodic table. They have an oxidation state of -1, -1. In ionic compounds, So when we have this particular question that is telling us about the atomic number is 17. So it's referring to chlorine, and it's commonly exhibits a -1 oxidation state in ionic compounds like sodium chloride, and up to +7 in ozo anions such as perchlorates, ClO4 minus, hence -1 and +7 are its typical oxidation numbers. Okay. All right. What process would coal undergo to give coal gas? Coal tar, ammoniacal liquor, and coke. Is it A, steam distillation, B, destructive distillation, C, liquefaction, D, hydrolysis? The right answer here is destructive distillation. Destructive distillation. Destructive distillation is basically the heating of coal in the absence of air, leading to decomposition into coal gas, coal tar, ammoniacal liquor, and coke. This is an industrial method for breaking down complex substances into simpler ones. So the right answer there is destructive distillation. Okay. The 10th question says that liquid black soap is made by boiling palm oil with liquid extract of hash. The function of hash is to provide the A, acid, B, ester of arachidonic acid, C, alkali, D, alkanol. Okay, so the function of hash is basically to provide the alkali, and ash from wood contains potassium carbonate, which forms potassium hydroxide in water. This alkali reacts with oil, which are triglycerides, in a saponification reaction to produce soap, making it the key agent for soap formation. Okay. When water drops are added to calcium carbide in a container and the gas produced is passed through a jet and lighted, the resultant flame is called an oxyl-hexane flame, B, oxyl hydrocarbon flame, C, oxyl acetylene flame, D, oxymethane flame. The right answer to this is oxyl acetylene flame. And basically, this is what happens. You have calcium carbide plus water, and that will give us, an alkyne, C2H2 plus calcium hydroxide. This reaction produces ethine, which is also referred to as acetylene. When ethine is bound in oxygen, it produces a hot blue flame known as oxyacetylene flame, used in metal cutting and in welding. The next question says, which of the following substances is a mixture? A, granulated sugar, B, seawater, C, sodium chloride, D, iron filings. And the right answer here is seawater is a mixture. And the reason is because seawater contains a mixture of salts, gases, and organic matter in water. It is not a pure substance and can be separated by physical methods like evaporation or distillation. Okay. If the quantity of oxygen occupying 2.76 liter at 0.825 atmosphere and 300 Kelvin is reduced by 1/2, what is the pressure exerted by the remaining gas? What is the pressure exerted by the remaining gas? Is it 1.650 atmosphere, 0.825 atmosphere, 0.413 atmosphere, or 0.275 atmosphere? The answer is 1.650. And the reason is using Boyle's law, which is P1V1 equals to P2V2. And in this case, our P2 is unknown. So we make P2 the subject of the formula. So it will be P1 multiplied by V1 divided by V2. Now, bringing in the values as given to us in the question, our P1 is 0.825 multiplied by 2.76, then divided by 1.38. And that will give us what? A 1.65 atmosphere. When volume is halved, pressure doubled, provided temperature remains what? Constant. Okay. So Four elements, P, Q, R, and S, have atomic numbers 4, 10, 12, and 14, respectively. Which of these elements is a noble gas? Which of these elements is a noble gas? Is it P, Q, R, and S? So based on the atomic number, we can actually know which one is a noble gas and which is not a noble gas. And if you carefully look at it, the right answer is option B, which is Q. Now, the atomic number corresponds to neon, a noble gas. Noble gases have completely filled outer shells, making them chemically inert. So when we look at it, you have a 2-8 system, that is 2 in the innermost shell, then 8 in the outermost shell. That's the octet structure. So it makes them to be chemically inert, and the right option there is Q because of that. Okay. So moving on now and looking at this other question, it says the product of the thermal decomposition of ammonium triazonitrate 5 are the product of the thermal decomposition of ammonium triazonitrate 5 are A, nitrogen 1 oxide and water, B, ammonia and oxide, C, nitrogen and water, D, nitrogen 4 oxide and water. Now, the answer is nitrogen 1 oxide and water. And why did we choose this option? When you look at the decomposition reaction for ammonium nitrate, what you have is N2O plus 2H2O as the product. So it decomposes into nitrous oxide, which is N2O, also called nitrogen 1 oxide, and water. So these are the products that will be formed from that decomposition reaction. How many valence electrons are contained in these elements with mass number 31 and atomic number 15, P? Is it 3, 4, 15, or 31? So how many valence electrons can we get from this? Looking at it closely, you discover that the valence electron is about the valence electron is the outermost electron that is contained in an element. And for this one, this is phosphorus. And the atomic number of phosphorus is 15. Now, its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p3. The electrons in the outermost shell, n equals to 3, are 3s2 and 3p3, which is 5 valence electron. However, the question asks for total electrons. So 15 is the total number of electrons, not the valence electron. But if valence electrons is intended as the question implies, the correct number should be 5, which is not an option. So this question is ambiguous, but by wording, most likely intended correct answer will be C, which is 15. So we need to actually clarify, because if you're looking at the valence electron, you're talking about the number of electrons that is in the outermost shell. And the outermost shell here is the 3s and the 3p shells, So it's 5. But because the question is not so clear, and that's why, and the options given, so the closest, relevant option that you can actually pick here is 15. Although it may look slightly incorrect from, chemistry standpoint, but because of what we have here, this is what you can say is the closest, because they are trying to refer to as the total electron, so we'll go on with 15. But in terms of the valence electron, it's 5. It's 5 for phosphorus. The same thing, if you look at for sodium, it is 1. For magnesium, it is 2. For aluminium, it is 3, like that, in that progression, So please, let's take note of that. The number of molecules of CO2 produced when 10 grams of calcium carbonate react with 0.2 dm cube of 1 molar HCl is, going by that equation that we have there, and then the options that are given, the answer here should be C, 6.02 times 10 raised to the power 22. How did we arrive at this? The moles of HCl equals to 1 mole per dm cube multiplied by 0.2 dm cube, which equals to 0.2 moles. Calcium carbonate molar mass is 100 gram per mole. Moles of calcium carbonate will be 10 divided by 100 with 0.1 mole. Equally, calcium carbonate requires 2 moles of HCl per mole. So HCl is in excess. The same thing, CO2 formed is equal to 0.1. So the number of molecules will be what, 0.1 multiplied by, the Avogadro constant, which is 6.02 times 10 raised to power 23. So when you do the multiplication, you end up having a 6.02 times 10 raised to power 22 as the correct answer. The volume occupied by 1.58 grams of a gas at STP is 500 cm3. What is its relative molecular mass? What is its relative molecular mass? Okay. Is it 28, 32, 44, or 71? The answer is 71. How did we arrive at this? Volume at STP is 500 cm3, which is equals to 0.5 dm cube. Okay. Moles equals to volume divided by 22.4, which will be equal to 0.5 divided by 22.4, which equals to 0.0223 moles. So the molar mass is simply mass divided by the moles, which will be equals to 1.58 divided by 0.0223. So that would give us 70.85, approximated to 71 gram per mole. Okay. Which of the following gases will rekindle a glowing splint? Is it NO2, NO, N2O, or chlorine? The right answer here is N2O. Nitrous oxide, supports combustion and rekindles a glowing splint. Oxygen and N2O are the primary gases with these properties. So they are the gases that can help rekindle a glowing splint. Nitrogen 1 oxide and then oxygen. So the right answer here is N2O, nitrogen 1 oxide. Okay. The shape of ammonia molecule is trigonal planar, octahedra, square planar, tetrahedra. It is the tetrahedra. Ammonia has 3 bonding pairs and 1 lone pair, giving a trigonal pyramidal shape. So ammonia has a 3 bonding pair and 1 lone pair, giving a trigonal pyramidal shape, which is based on a tetrahedral geometry. So looking at this particular question, the shape of ammonia molecule is it trigonal planar, octahedral, square planar, or tetrahedral? And we said the right answer is D. It is tetrahedral. And the reason is because ammonia has 3 bonding pairs and 1 lone pair, giving a trigonal pyramidal shape or pyramidal shape, which is based on a tetrahedral geometry. If tetrahedra is among the options without trigonal pyramida, then it is the best. It's the best fit. But because it's not there, that will suffice. A few drops of concentrated HCl are added to a 10 cm cube of a solution with pH 3.4. The pH of the resultant mixture is less than 3.4, greater than 3.4, unaltered, the same as that of pure water. The answer is A, less than 3.4. And adding HCl, a strong acid to a solution, increases the hydrogen ion concentration, thereby lowering the pH, okay? Chromatography is used to separate components of a mixture that differ in their rates of, is it diffusion, migration, reaction, or sedimentation, okay? The right answer to this one is migration, B. Now, the reason is because chromatography separates components based on their different rates of migration over a medium, e.g. paper, gel, under the influence of the solvent. So you have the mobile phase, then we have the what's it called? The components separating based on how fast they can move through either a paper or a gel, as the case may be, you know. The liquescent substances are also efflorescent, anhydrous, hygroscopic, insoluble. The right answer is hygroscopic, and explanation is just that the liquescent substances are extremely hygroscopic. They absorb moisture and dissolve in the absorbed water. Okay. Helium is used in observation balloon because it is light and combustible, light and non-combustible, heavy and combustible, heavy and non-combustible. So the answer to this one is because it is light and non-combustible. Okay, B. So unlike hydrogen, helium is non-flammable and lighter than air, making it ideal for balloons and safe for use. 32 grams of anhydrous copper 2 tetraoxosulfate 6 dissolved in 1 dm cube of water generated 13.0 kilojoule of heat. What is the heat of solution? Is it 26.0 kilojoule per mole, 65.0 kilojoule per mole, 130.0 kilojoule per mole, or 260.0 kilojoule per mole? So the answer here is 65.0 kilojoule per mole. And the reason is because molar mass of copper sulfate is 160 gram per mole. The number of moles here is 32 divided by 160, which is 0.2 moles. Now, heat per mole equals to 113.0 kilojoule divided by 0.3 moles. So that will give us 65 kilojoule per mole. Okay. A gaseous metallic chloride, MCl, consists of 20.22% of M by mass. The formula of the chloride is it MCl? Is it MCl2? Is it MCl3 or M2Cl6? Now, the answer to this is MCl3. How did we arrive at this? Assume the formula is MClX. Let's calculate percentage of M in MClX. Molar mass is 27 plus X, that is X times 35.5, okay? Now, when we set up the equation, we have 27 over 27 plus 35.5 X, 0.5X multiplied by 100. So when you do this, you have a resultant of 27 divided by, let's take that again. Let's start again from the top. No, it said assume the formula is MClX, you know. Now, let's calculate the percentage of M in MClX. Molar mass is 27 for M. Don't forget that 27 plus X times 35.5. Now, when we set up the equation, we have 27 divided by 27 plus 35.x multiplied by 100, which will be equal to 20.22, which is the percentage, okay? If that is the case, it means that our 27, when we do a cross multiplication and all that, and we flesh it out as we calculate, you discover that your X will be equals to approximately 3. Hence, the formula is MCl3. So that's how we arrived at that. The next one says that what quantity of electricity will liberate 0.125 moles of oxygen? What quantity of electricity will liberate 0.125 mole of oxygen molecule during the electrolysis of dilute sodium chloride solution? So the answer to this one is actually B, 48,250 coulombs. Now, how did we arrive at this? At the anode, we have water, and then we have oxygen plus 4 hydrogen plus 4 electrons, okay? So 1 mole of oxygen requires 4 moles of electrons, which equals to what? 4 Faradays. 0.125 moles of oxygen will be equals to what? 0.125 times 4, which will be equals to what? 0.5 Faradays. Now, Q will be equal to what? 0.5 multiplied by 96,500. That will give us what? 48,250 coulombs. And that's the quantity of electricity that will be liberated when 0.25 moles of oxygen molecules undergoes when there's electrolysis of dilute sodium chloride. So that is what we'll have there. Okay, moving along now. Which of the following types of bonding does not involve the formation of new substances? Metallic bond, metallic covalent, coordinates, or electrovalent? The answer to this is metallic, metallic, metallic. Now, the reason is because metallic bonding occurs between metal atoms in a pure metal. No new substance is formed. The other type involves chemical reaction and the formation of new compounds, okay? So the next one says that an organic compound that does not undergo a reaction with both hydrogen cyanide and hydroxylamine can be alkene, alkanal, alkanone, or alkanoic acid. So the right answer to this one is alkanoic acid. And the reason is because hydrogen cyanide and hydroxylamine react with aldehydes and ketones. Alkanoic acid do not react with hydrogen cyanide or hydroxylamine in this way. Okay. The next one says that the substance often used for organization of rubber is A, chlorine, B, hydrogen peroxide, C, sulfur, D, tetraoxosulfate, 6, acid. The right option is sulfur. For vulcanization is the process of heating rubber with sulfur to improve elasticity and the strength of the rubber. Okay. The chlorinated alkane often used industrially to remove grease is it tetrachloromethane? Is it chloromethane? Is it trichloromethane? Is it dichloromethane? So the right answer to this one is tetrachloromethane. And the reason is because it is also called carbon tetrachloride. It is a non-polar solvent effective in removing oils and grease. Okay. This one says that what mass of water is produced when 8 grams of hydrogen react with excess oxygen? Is it 8 grams? Is it 16 grams? Is it 36 grams or 72 grams? The answer to this one is based on this reaction that we have here. You look at it stepwisely, you discover that 4 grams of hydrogen produces 36 grams of water. Therefore, 8 grams of hydrogen will produce what? 72 grams of water. So, and that's basically it. So if you look at it from this equation, hydrogen plus oxygen give us 2H2O, right? That means if 4 grams of hydrogen produces 36 grams of water, therefore 8 grams will produce what? 72 grams of water, just a multiply effect, you understand? And that's how we arrive at the option, and the right option there is option A. Proteins in acid solution undergoes, is it substitution, fermentation, hydrolysis, or polymerization? The answer is hydrolysis. Proteins are hydrolyzed by acid into amino acid through the breaking of peptide bonds. Okay. Then the general formula for alkanal is R2CO, RCHO, ROH, RCOOR. What is the general formula for alkanals? The right answer to that for that one is B, which is RCHO. Alkanals have the general formula RCHO, where R is an alkyl group and CHO is the aldehyde functional group. Okay. When cathode rays are deflected onto the electrode of an electrometer, the instrument becomes bipolar, B, negatively charged, C, positively charged, D, neutral. So what happens when cathode rays are deflected onto the electrode of an electrometer? It is negatively charged, and the reason is because cathode rays are streams of electrons. When they strike the electrometer electrode, they impact a negative charge to it. Okay. All right. When a solid substance disappears completely as a gas on heating, The substance is said to have undergone, is it A, sublimation, B, crystallization, C, distillation, or D, evaporation? The answer is sublimation. And sublimation is basically the direct transition of substance from the solid to the gaseous state without passing through the liquid phase. Okay. Example includes iodine and then ammonium chloride. Okay. An electron can be added to a halogen atom to form a halide ion with 8 valence electron. Is that when an electron is added to an halogen atom, it will form a halide ion with what? Is it with 8 valence electron, 7 valence electron, 2 valence electron, 3 valence electron? So the answer to this is 8 valence electron, and halogen group 17 elements have 7 valence electrons. When they gain 1 electron, they achieve a stable octet configuration, that is 8 valence electron, forming a halide ion, and that's X minus. So that's the answer to that. This one says that aluminum hydroxide is used in the dyeing industry as A dye, B, a dispersant, C, a salt, and D, a mordant. The answer to this one is D, a mordant. And the reason is because a mordant is a substance used in dyeing to fix dyes onto fabrics. Aluminum hydroxide helps the dye bind permanently to the clothes. Okay. The most important element on the Earth's crust is it nitrogen, is it hydrogen, oxygen, or fluorine? Well, the most important element is basically oxygen. Why is it oxygen? It's pretty straightforward. It makes up about 46% of the Earth's crust by mass, mostly in the form of oxide, silicates, and water. It is the most abundant and chemically reactive non-metal in the Earth's crust. So that's the reason. So this one says that, oh, we've got, okay, let's just flow with it like that, sorry. To obtain pure carbon-2 oxide from its mixture with carbon-4 oxide, the mixture should be A, passed over heated copper-2 oxide, bubble through water, bubble through concentrated H2SO4, or bubble through concentrated NaOH. And the answer is D. It should be bubble through concentrated NaOH. And the reason is because carbon-4 oxide is acidic and react with NaOH, forming sodium carbonate. Okay. While carbon-2 oxide is neutral and does not react, so it remains behind as the gas, as the pure gas. Okay. All right. See, thank you very much for joining me in going through this particular year's past question, or this particular year question. So we'll be moving along again. We'll look at other years, and that will be very shortly. So stay tuned, and let's keep learning. Thank you.